Go.
So why is motility important for bacteria? It's important so they can move out of dangerous situations or into situations where they can acquire more nutrients. So there's two types of motility. One, they use a flagellum. The second is like a gliding motion. So the flagellum kind of, it looks like a little tail, and they use it like a propeller. So it kind of spins in a circular motion, just kind of like how a boat would, I guess. And then the second type is gliding. According to Google, they glide over surfaces by mechanisms that remain a mystery. So we're not really sure how to describe that, but just kind of think of it as like a little slug just moving along. And gliding motion, that's less for traveling and more for survival.
So for the shapes, you have three different basic shapes, and I'm probably not going to pronounce these right, but the cocky, the bacilli, and the spirals. So you have several different types of the cocky, and there's the diplococky, and that's just like the two cells. And then the streptococky, which is multiple in like a string-like formation. The tetrad, which is four of them in a square formation. The staphylococky, which is multiple of them kind of in a flat formation. And then a sarcina, which is like a cube formation of 8 cells. And then you have the bacilli, which is a chain, is just multiple of them in a string. The flagellae rods are just like one of them with multiple projections off of it. And then the spore former, which is, it's just a cross section here of it, like kind of like looking like an end of a needle. And then the spirals, you have the vibrissae. I don't know how to say that, but it's one of them with like a little tail, and then the spirilla, which is one of them with multiple tails on the end, and then the spirochetes, which is just like one of them in the spiral formation.
Excellent. For cell wall, we have two different types. One is gram-positive and one is gram-negative. That comes from the gram staining technique. And for the gram-positive, it's going to be stained purple in the gram staining technique. It has a thick peptoglycan section, one inner plasma membrane, whereas the gram-negative would be stained pink. And it has a thin peptoglycan layer in the middle, and two membranes, one on the inside and one on the outside. Here you can see that the outer membrane has that word alipo something membrane on the top, whereas the protein layer of peptoglycans in the middle, it's very thin. The bottom layer is the inner membrane, which is a phospholipid membrane. Over here with the gram-positive, you have the thicker peptoglycan protein layer and then the inner membrane of the phospholipid lipid layer.